This video is the first part of a series I'll be doing on the basics of binary exploitation, where we go through some practical buffer overflow exercises. And as you can see here, we'll start off with the basics and we'll work our way up to more complex examples. I'll try to do 32-bit and 64-bit in most of the examples where there's going to be any differences anyway. And we'll use a lot of different tools and techniques, so we'll be checking out some debuggers and disassemblers and getting to use pwnTools scripts and things like that. I will be focusing on the practical side of things here, so we'll be doing very little theory, but I've listed some additional resources down here that you can check out. I recommend Ironstone's notes are very good for learning the basics, so you can go and check out all the basics, a lot of stuff that we'll be covering here as well. And Nightmare, these are great for looking up previous CTF write-ups for pwn and reverse engineering challenges. You've got some more here as well. I know Pink Draconian's doing a reverse engineering series at the moment, so they'll be covering things in a lot more detail in terms of going through diagrams and stuff that I'm really not doing here. I'm just going to show how to exploit things practically, and I'll talk through a bit of theory as we go as well. There will be a lot more advanced stuff that I don't cover in here, but if you go back to my GitHub repo as well, I've done some other pwn walkthroughs. I did the ROP Emporium series, although the video quality is not as good. Hopefully this one's going to be better, this series, but the technical difficulty of the challenges is far higher. And then just in general, if you go and check out some of the CTF events or the Hack the Box write-ups, quite a lot of these I've published scripts and videos for, so you can go and follow along with the video and the script if you want to see some other examples. But in this case, we'll just be going through, where is it? Pwn, binary exploitation. We'll just be going through these examples, but this should give you enough to be able to go and get started with more complex challenges. So we're going to go look at some of the tools that we'll be using in most of the episodes shortly, and we'll do a very basic buffer overflow example just to show how we can open those tools and do the basic stuff. First of all, I'm just going to go over to this article which I've left in the description. It just gives you a formal definition of what a buffer overflow is and some more description down here, which I'm not going to read through all the text, but let's just say that we have our stack here in this diagram, and whenever a function is called, we have our function on the stack, we have our parameters, we have the return address, and then we have our base pointer and then the buffer where all the local variables and things are going to go. So the point here of overflowing the buffer is to overwrite some of these other things that we have on the stack that shouldn't be controllable by the user. So if we overwrite the base pointer and the return function, we can potentially control where the program goes next. Instead of returning to where it should return, maybe the main function, we can tell it to go to another function. Or we can tell it to go to some malicious code that we've also injected onto the stack. And that's just the very basics. That's all I'm really going to do. We'll talk about it more as we go through some of the demonstrations. One thing to say as well, I'll be repeating myself a lot throughout this series, so if I'm repeating myself a lot, hopefully most of the stuff that I'm repeating is stuff that's either what you need to remember or stuff that's important. So I know that sometimes, there might just be one episode that you go to watch. For example, if you want to learn how to bypass stack canaries, and then you're not going to hear all the stuff that was said earlier in the series. So hopefully it doesn't get too repetitive, but if it does, hopefully it's the things that you need to remember anyway. So I'm going to mention some of the tools that we'll need on most episodes anyway. We're going to need a disassembler. Now you can use a lot of tools to do this. We're also going to need a debugger as well, but quite often you get programs that do the same thing. So for example, GDB we can use as a debugger and as a disassembler. The same with IDA Pro, the same with Geardra, but I typically use GDB pwndebug for debugging and then use Geardra for disassembly and decompiling the code as well. I'm just bringing this up here. Here's a link which I'll leave in the description. There is a tool to automatically create a Geardra project and import and analyze the binary that you want to target. And it can just speed things up, because otherwise it takes quite a while to just create a project and import the binary and analyze it automatically. So I'll leave this here. You should just be able to install Geardra with sudo apt-get install. On Kali now, I'm on Parrot at the moment, but it's quite similar. So just pick your operating system, make sure it's a Linux one anyway. And Geardra, if you want to use IDA Pro, or you can use Binary Ninja or Adair or Hopper, there are various tools, but I'll be using mostly Geardra and GDB pwndebug in this example. So let's just also have a look at GDB pwndebug, because GDB is installed on Linux by default on most and nearly all Linux distributions, but we can use these plugins like pwndebug or Jeff or PEDA, and they're all plugins which help with binary exploitation. What I actually have is I followed this article, which I'll leave in the description, to install all 3 of them so that you can quite easily swap between the different plugins. Having said that, I pretty much only use PwnDebug these days. So if you want to do that, you can follow this article. If not, I recommend setting up PwnDebug at least. We're also going to be using the tool checksec, which I think might be installed either with pip install, or it might come with PwnTools or something. If not, again, I'll leave a link in the description to this checksec script, and this will tell us what binary protections are enabled, and we'll go through those in more detail as well. We're also going to be using Ropper, probably not for a while, but I think we can install this with pip install. Yep, so I'll leave a link in the description. You just need to install some dependencies properly, probably, and then install Ropper as well. Finally, the other most important thing is PwnTools. Let me grab a link. So all these are in the description. There's also a tutorial here which will go through the basics of PwnTools, but we will be covering quite a lot of it in the videos. And you can install that again, it's just like pip install pwn. That will provide quite a few extra tools that we can use in the command line. For example, like the cyclic command, and I think hex and unhex come with it. So we can do stuff like hex ABC, it gives us a hex, unhex. Okay, I think we've been over all of the key tools, so let's go and actually try some of them out. So let's go into the first directory, and you can see what we've got here. We've got vuln.c and we've got vuln. I use Codium normally as a development environment, so I'm going to open this up with Codium, but you can open it up with something else of your choice. Very simple program. We've got a main method with a buffer of 16 characters, and it's taking in some data, it's asking us some data, and it's going to read that in with gets. And what we should know about gets is it's a dangerous function. If we search for the manual here, if we have a look through, we'll see here under bugs it says never use gets, because it's impossible to tell without knowing the data in advance how many characters gets will read, and because gets will continue to store characters past the end of the buffer, it's extremely dangerous to use. It has been used to break computer security. So that's telling us that this function is inherently dangerous to use, and basically what it's telling us is it doesn't automatically check to make sure whatever we put into that buffer is going to fit. So it's telling us to use fgets, because if we have a look at fgets, we'll see that it actually takes in the size. So we have to make sure that we specify a size whenever we're calling fgets. In this one we don't, so somebody can enter in more than 16 characters. And what we saw from that example earlier is if we've got a buffer of 16 characters and we enter more and the program doesn't do anything to stop us from doing that, it's going to go up and it's going to start overwriting all this other stuff on the stack. So this is already compiled, but let me just show how we would compile this as well. And let's also check the file type. So we want to see, is this a 64-bit or a 32-bit executable, and it's 32 bits in this case. We also want to know if it's dynamically or statically linked, so you can see here it's dynamically linked, as most programs are. And what that means is we have these functions here like printf and gets, which are in the libc library. So rather than including all of the code for these functions in this file, it's simply going to look out to the libc library that's on the computer system that's being run on to see what is the location of this function, and then it can call it from there. So that's pretty important. We'll look at that more later. We also can see that it's not stripped, which means that if we reverse this, we'll be able to see the function names and things like that. It'll be a little bit easier to analyze. So we're going to compile the binary. As we'll do this, you can see we've already got a compiled binary here, but I just want to show that in quite a lot of these videos we'll be compiling using different settings in terms of the security settings on the binary and maybe just the architecture. So we can use GCC, and let's do vuln.c. The output is going to be vuln. And then in this case I'm going to just add this fstackprotector -all. You can see it's given us a warning because we've used gets. It's just telling us that's dangerous, you shouldn't have used it, but it's still giving us the binary anyway. I use the fstackprotector-all because I just want to demonstrate this other tool that we talked about, checksec. So we'll do checksec file vuln, and we can see here that we've got a 64-bit little endian application. And we've got all this red text basically to say that these protections are on. So it's got stack canaries, It's got NX enabled, so no execute is enabled, or data execution prevention, and pi is enabled as well. And we're going to turn most of these off at the beginning, but we'll start turning them on as we go through the videos to see how we can defeat some of these protections. But I'll not go through all of these now. I'll save those for some future episodes, and we will be going over them in most episodes just so that we really get to remember what all these are and what they mean. Okay, so let's also compile it. I'm going to compile this in 32-bit. Let's bring up that again. This time we're going to do F no stack protector, F no dash stack protector, and we're also going to turn off the NX, so we'll do dash Z XX stack. We're going to turn off pi, so we'll do no pi, and we'll do it 32-bit as well. Now if we, I typed one of those in wrong, exec stack. Now if we run checksec again, so you can see that all of the protections are now disabled, and we can also see that it's 32-bit here as well. So we had all red, and now we've got all purple. So that's our first tool, checksec, looked at. We'll have a look at what these protections are later, but for now let's just try and overflow this buffer. So we've created the file. You might need to make it executable, chmod x plus x, and provide the binary. We'll try to run it, and it's just asking for data. We can just put in some, well, we know that it's a 16 character buffer, so let me do 4 A's, and let me copy and paste this 4 times, and we've got a segmentation fault. So we haven't done anything interesting, but we've crashed the program, so we've overwritten something here which was important and something that was needed for it to keep running. Let's try and do that again, and this time 1 2 3 and then 1 2 3. Oops. And that was fine. So we entered 15 A's and we didn't get any problems. So let's go and check this out in another tool, and that's GDB pwn debug. So if you installed all 3, you should be able to type gdb-pwn debug, and this will bring it up. We can then do, I could have provided the file there as a parameter, but I forgot. So instead I'm going to say file and pass in vuln. We can do info functions to see what functions we've got here. And in this case we've only got our main function, but we have these other libc functions that will be used as well. And I mentioned that this was, as well as a debugger, is also a disassembler. So if we wanted to disassemble a function, we can say let's disassemble main, and we can have a look at the assembly code here. We could jump to different addresses or jump to different functions if we wanted to inside the debugger. And we can set up breakpoints. Let's, for example, set a breakpoint at main. Let's run the program, and you'll see immediately we've hit this breakpoint at main, and this is showing us everything on a stack. So we can see our registers up here, we can see what's being called here, the instruction. This is the current instruction in the instruction pointer, the EIP. There's our stack pointer, our base pointer, and our registers. And we can see the stack down here as well. You can also do something like info stack, or we can use X to represent a, let's say, a register. Let's do EAX. You can print it as hex, or you can just print it as a decimal, or whatever format you want really. We'll go through some of this a bit more as we go through, but if we want to just continue from here, well, let's actually say before we continue, if we wanted to just step through these instructions one by one, we can type next or N, and you'll see that goes on to the next instruction. Again, we type N, and we can keep going through, but I'm just going to hit continue. And this time around, I'm just going to type in crypto. So we've not overflowed the buffer, we just entered in a normal string as it was expecting. I'm going to delete the breakpoint so it doesn't hit that breakpoint again. I'm going to run the program again, and this time I'm just going to enter in some A's. So let's put in a load of A's. We run through the program, and this time we hit a breakpoint even though we didn't actually set one. So what's happened there is we got the segmentation fault. Remember, if we put in 16 characters or more, we're going to crash the program. And it's basically showing us the state of the registers and the stack whenever that happens. So we can see our registers are all filled up with A's. We can see that we've got A's in our ESP. I'm not too sure what the square bracket there was. And typically in our buffer overflow we would see the return pointer here as well. The EIP would also be filled up with those A's. In this case we're not returning to another function. So this isn't a great example, but we're able to see at least the state of the stack and the registers. Let's do info stack. Okay, not showing too much because it's an invalid memory address now because we overwrote the stack pointer. But I just want to show that as a basic example anyway. We're just trying to show our way around some of these tools like pwn-debug. And the last tool we want to look at is Geardra. So I'm going to open up Geardra. I'm not going to use the automatic scripts that I normally use because I just want to show how to demo this. So we just go File, New Project. We'll create a new project. I'll just call it binexp. And let's import the file. File again. Import and go and find the location. And import the binary. Click OK. OK again. Double click the binary. Click Yes to analyze. Click Analyze. And then we're through to Geardra where we have our decompiler on the right. We've got our assembly code on the left. And then we can see our program sections up here. We've got our imports and our exports, so those libc functions for example. And we have the functions here as well. So we're going to start off at our main function. The only time you wouldn't start here really is if you have a stripped binary, and then you'll start off at the entry and try and work your way from there. And you can see that we have this decompiled code on the right. And this is very close to what we saw in our C code. If we go back and have a look, we've got that buffer of 16 bytes. It's calling printf, then it's calling puts. It's not quite the same, so you wouldn't be able to just copy and paste this into a compiler, although you can normally do that with some minimal changes. We can also easily rename some of these variables. So for example here we have our 16-byte buffer, so we might want to rename that. Oh sorry, you can't rename it there. You can type L to rename, so I'm going to rename that to buffer, or you could rename it password or whatever it is, data. And notice that whenever I'm clicking on different lines here, it's also highlighting them in the disassembled code on the left. So this was the code that we saw in GDB whenever we disassembled the function, and we have all of our memory addresses here to show which instruction it's pointing to, which is handy because obviously if we want to redirect the execution to a function of our choice or to some code of our choice, it's going to be useful to know where those functions are. Apart from that, in Geardra you can search for strings, so quite often if you're doing like a capture the flag competition, or if you were bug hunting on a real binary, quite often you won't have access to the source code, you'll just have the binary, and you'll want to go and disassemble, decompile it, and maybe search for strings to see if there's anything of interest. If you saw something here that said flag or password, you could click on it and then go and see whereabouts is that referenced in the code, and you'll actually see, okay, there's a reference here. You can click on those references and then go and have a look through the code. But we'll be using this in quite a few. In most of the videos we'll try and compare what we see in Geardra to what we see in the C code, bearing in mind that if you're doing a CTF you probably won't have all of this code to analyze. And lastly, I mentioned Ropper, which we're not going to need for a while, but let's just demo it while we're looking through some of these tools. So we can use Ropper, we can pass in the file just like we did with checksec, and it will basically tell us what's the address of all the ROP gadgets in the program. So these are just chains of instructions which you can then use in your buffer overflows, and we'll start using them towards the middle of the series probably. You can also use that to search, so we can do like search, and for example you see that ret instruction there, let's search for ret and it will bring that back. We're not going to really use that for now. Let me also just show, just in case you do want to see some other tools to do the same sort of stuff that we're doing, you can use Radar, so we can use Radar vuln. You can do AA or AAA, however many A's. Oh, not that many A's, 1, 2, 3, 4 I think is the max, just to analyze the functions. And then we can do AFL to list the functions, and then we can go and drill into these functions as well. So we can do, I think PDF main, I've not used this in a while, no, not PDF main, S main PDF, and that'll disassemble it. We can put it in like graph view as well, I think capital V. Yeah, I've not used this in a while, but everybody has a different preference of tools, so you can use this. You can also use IDA Pro as well. A lot of people would use that, and I use that a lot myself in the past, but I find Geardra to be a bit easier to work with nowadays. Okay, so I think that'll do it for this video. I don't want to go over too much stuff and confuse everybody, and I will be going through a lot of this stuff again, so just a very quick introduction to the tools that we'll be using and the sort of things that we'll be covering. And again, just to mention, if you go back to my GitHub, to the CTF part of the GitHub, there's a lot of different walkthroughs and stuff here and links to files to go along with videos, but I've also put together a list of resources of sites that you can use to go and practice pen testing skills, as well as buffer overflows, web challenges, things like that. So these are some of my favorite sites, or sites that have been recommended, and a lot of different creators as well. Some of them do a lot of binary exploitation stuff. This is actually the playlist for Live Overflow. Oh no, I think that's the CTF playlist, but he's got some binary exploitation. Same with John Hammond. Quite a few of these anyway. I know Pink Draconian's doing quite a lot at the moment. Superhero. So you can check those out. There's more resources here. Some of them I mentioned earlier, like the Nightmare resource, which will have a lot of different useful scripts if you're trying to solve new challenges. Alright, that's enough talking from me. I hope you've enjoyed this video, and stick with me for the rest of the series.